Okay, kids, I'm going to try and do some problems that are very similar to what's in the book. There are some great problems available in the book, and I'd like you to be brave enough to try them. There's 30 problems, and they're doable. So I'm doing problems that aren't in the book, but they're like in the book. So there's some problems about proving that hyperbolic triangles are congruent. Well, it's not that much different from proving Euclidean triangles are congruent. You got to find reasons for pieces of the triangles to be the same. So we've got a hyperbolic circle, and it's called by its name, center H. So that's the hyperbolic center is H. And the hyperbolic line, AB, is as pictured. Now, with that center right on this line, we've seen this. This is like from a week 1 or week 2 wiki problem. We automatically get right angles here. These hyperbolic angles where this bent hyperbolic line, this circle, meets this straight one, that's going to be 90 because the radius drawn to the point of tangency automatically is going to be a right angle. And that's how you measure the angle, is with the tangent. So the tangent's already going to be a right angle at that because the one side's already straight. So the angle between this straight line, the Euclidean straight line, and this bent Euclidean line is still going to be 90. So I got a pair of 90s if I want them. I got a shared side, OH. I got a side in common. That's good. And then if I could just get another pair of sides, these two, I'd have side, angle, side. Can I come up with a reason why HB and HA are the same size? Well, obviously, H is the hyperbolic center. This is a line that goes through the center, so it must be a diameter. These must be radii, which means they're the same size. So we've got a lot of symmetry here. It looks like we got a lot of symmetry, and in fact, we do have a lot of symmetry. So let's lay down the pieces. I've got OH congruent to OH by reflexive. That's the segment they have in common. We have those 90 degrees because the center, C, is on OH. So I got something going through O. That's Euclidean straight. So that's a very nice, fast way to get 90-degree angles. And then we've got two radii of the same circle. So that's side, angle, side. The triangles are congruent by side, angle, side. Now there could have been further questions. Like, for instance, we'd also have a reason that angle A is equal to angle B because they are corresponding. Do you see? Angle B is the second letter. Angle A is the second letter. So those angles correspond, and if you look in the drawing, angle A and angle B are the same angle in the same position in these two triangles. Well, the two triangles are congruent, so angle A and angle B have to be congruent by corresponding parts. Corresponding parts of congruent triangles are congruent. So that's a typical problem. You would, if it was proved the triangle is congruent, you'd stop there. But it might have been proved that angle A equals angle B. Well, then you prove the triangles are congruent and use the corresponding parts. Then there's one more question. Do you see it down here? So that cosh OA is equal to cosh HA times cosh OH. That's referring to this one hyperbolic right triangle right there. Well, we have a formula in the book. It's on, I believe, page 86 or 87. Let's go see it real quick. And it is this one, this formula right there. It says cosh C equals cosh A, cosh B, minus sinh A, sinh B, cosine C, where C is the angle opposite the side. So I have the angle C opposite the side C. Angle C, big letter, side C, little letter. Well, that's what we have. I have, in this problem, cosh A, cosh OA. OA is this side, and opposite that is a 90-degree angle. So let's do that formula. That formula says cosh OA would be equal to cosh HA times cosh OH minus sinh HA times sinh OH times the regular old cosine of angle OHA, and angle OHA is 90, so that's a big fat 0 for that factor, making this whole factor here 0, and we get what was supposed to be shown. These problems are doable. You got to give them a try. You just got to give them a try. They're not bad. The book problem is an easy source of points because look how skinny this book is. You can carry this book around anywhere, and you can try these problems on a piece of scrap paper. and just go for it. You'll get something good. All right, one more book-like problem. We have to construct. There's a bunch of construct problems. Let's say we wanted to construct a hyperbolic quadrilateral with 3 right angles. Well, let me show you how this goes if you're not too careful. I thought, well, let's try it. Let's just give it a try. So I'm using the idea from that problem that I had right here, that I can get some very fast right angles by using the straight line through and then put the center of my hyperbolic line on that straight line. I get free right angles. I want to do that. So I took this 90-degree angle on the graph paper. I went straight out and I put the center. Here's the center here. I had to do a construction. I had to do the inverse of this point. This is way over here, if you look at it. The inverse of that point way over here. I did the midpoint, the perpendicular bisector construction, got the midpoint, put the point of my compass there, drew, and I got this nice hyperbolic line. Then I copied these distances over here, and look, the hyperbolic lines missed each other. This distance is too far from O for me to get the rest of my quadrilateral. I get 3 right angles, but my quadrilateral didn't close up. Well, that doesn't mean you quit. You try it again, and you got to bring these points in a little closer is what you got to do. So let's try it again. So here I go. I'm going to bring those points in nice and close. I'm going to go and see if I can get the inverse of this point. I hope it fits on the page. Let's see if it does. I got to come down here. See, I'm following the graph paper. So I'm going to come down to this point with my ruler. I'm going to do that and see if that'll fit on the page. So I got to do a right angle from there. Just trying to get a fast right angle there. Oh, it's going to go off the page. All right, let me try from this point then. So I'm going to come back out here, come up to there, and try that perpendicular. Does that stay on the page? It does. So I'm in business with this construction. I can fit it on my page. So there's a point and its inverse. They're really far apart, but I don't care. It fits on the page. Now I need the midpoint. So I grab my compass and I make my distance more than half the total distance. This looks, I might want to add a little bit more to it just to make sure these things intersect. So then I run over here to this point, and there's all I have to do to get the midpoint. So here's a point and a point to put my compass or my ruler on, and there's where that midpoint is. So when I put my compass point on there and I adjust to catch this point, check it out, okay? It should catch its inverse point back over there, and it does. So that guarantees that this is a hyperbolic line. Now, I'm going to see if I can fit this thing on there. I would like to do the same hyperbolic line from up here, because if I can do that, then they'll intersect. So I'm going to do a lazy thing. I'm going to just come over here and copy that distance. I'm getting that distance, and I copy it up here. It barely fits on the paper. I win. Now I got to go back to the original radius. And all I have to do is stick the point of that compass right there and check it out. Boom. It's beautiful. There's the 4 points of my hyperbolic quadrilateral. Can you see it? So I've got a right angle there because the center is on that straight line through O. And I've got a right angle there. And I used the graph paper to get that right angle. I got 3 right angles. That forces the 4th angle to be acute. That was an old wiki problem. Remember, you can't get Euclidean sizes. I can't have that 4th angle be 90. But it can be any size less than 90. It could be 20, it could be 30, it could be 89. But it can't be as big as 90 because that would be a Euclidean angle sum for the whole thing. And that, ladies and gentlemen, is it. Look, it wasn't that bad. Even after I had made that mistake where the pieces missed each other. You know, the pieces missed each other. It's not that big a deal. You just try again. Use your newly found wisdom to your advantage and finish this thing. And then take a picture, shrink the picture beforehand so I don't have to shrink it, and post it and get your points. You know, it's not so bad. There's a bunch of problems in the book that are doable. So go out there and get your points.